Imagine one silent night in the vastness of space, far from the beckoning reach of radio antennas and telescopes, a sudden and previously unknown event begins. Within the dark curtain of our solar system, amidst the swirling winds of Jupiter, the cold emptiness beyond Neptune, something stirs. A ripple, at first infinitesimally small, imperceptible by any instrument, grows at the edge of interplanetary space. This is no ordinary phenomenon. What is forming is a wormhole, a bridge between two disparate points in space-time, an enigmatic tunnel long theorized by the most brilliant minds, yet never observed by human eyes. As hours progress, the warp in space intensifies, fueled by exotic energies we cannot begin to measure. An event horizon takes shape, invisible yet potent, spinning cosmic particles and solar wind around it in swirling spirals, bending the very fabric of reality. Astrophysicists on Earth, sifting through streams of data, notice something irregular. Probes at the periphery of the solar system record anomalies, gravitational lensing, and shifts in the paths of distant asteroids. Coordinates home in on a strange region just beyond Pluto's orbit, a place now marked by inexplicable fluctuations in electromagnetic radiation, the hallmark, perhaps, of a wormhole's mouth. Panic doesn't break out, but excitement visibly bubbles in the global scientific community. Here, against the odds, is a real, unexplained phenomenon, possibly a shortcut through space and time. Governments and space agencies fast-track plans. Telescopes swing their eager gazes outward, and data crunches late into the night. Teams at NASA, ESA, and other agencies urgently coordinate, modeling possible repercussions, designing new protocols for planetary defense and exploration alike. To the layperson, it may seem like science fiction. After all, wormholes are a staple of speculative stories, depicted as swirling portals or gateways across the universe. Now those conjectures are on the precipice of reality. In the weeks following the discovery, the world unites in curiosity and apprehension, poised to witness, or participate in, an event that could alter the trajectory of civilization for generations. Yet before anyone dares to approach, questions must be answered. What exactly is a wormhole? What would lead to its spontaneous formation in our solar system? And what promise or peril could such an anomaly pose? A wormhole, also called an Einstein-Rosen bridge, is a theoretical passage through space-time, predicted by solutions to Einstein's general theory of relativity. This vision arose from mathematical descriptions of how massive objects warp the geometry of space and time. While gravity bends the path of light and governs the fates of planets and stars, it also allows for more esoteric realities, including these cosmic shortcuts. Imagine space as a fabric that warps and folds. Place two distant points together, link them not by the long journey over the surface, but by a tunnel directly beneath. That is the essence of a wormhole. If such a structure formed in our solar system, it could arise through mechanisms as mysterious as quantum fluctuations, the collision of cosmic strings, or technological intervention by an advanced civilization. The actual process lies beyond our current technological limits, but its implications captivate the imagination. At the first moment of discovery, the focus falls on safety. The physics of wormholes suggests they could significantly distort local spacetime with unpredictable gravitational effects. Sensitive satellites begin to pick up strange perturbations in the orbits of small distant bodies. Rocks and ice that dwell in the Kuiper Belt now drift from their regular paths. Sedna, a distant dwarf planet, seems to wobble, its centuries-long trajectory abruptly altered. These are subtle shifts, but unmistakable. Astrophysicists convene in hurried meetings, video conferences spanning continents. The first step is understanding if the wormhole is stable. Classical theory suggests a traversable wormhole requires so-called negative energy or exotic matter to keep it open. Otherwise, the tunnel would collapse instantly, or worse, become a region of violent instability. Existing physics offers little guidance, and even experts argue over whether such structures can persist naturally or only through immense artificial effort. As more data flows in, it appears the wormhole is relatively stable. This implies that the exotic energy requirements, or quirks of quantum gravity, are somehow present. Is this natural? Artificial? The question divides even the greatest minds. Some speculate about cosmic accidents. Others propose deliberate creation. There are whispers, promptly dismissed but not forgotten, of extraterrestrial intelligence. Earth waits, holding its breath. What would it look like? From close by, the wormhole would appear as a sphere, black as a shadow, yet surrounded by light. Its intense gravity bends the path of nearby star light so that the backdrop is warped and twisted, forming a halo of distorted stars. A ship daring enough to approach would feel increasing tidal forces as the difference in gravity from front to back intensifies. Yet, there is no catastrophic event horizon, at least not in a traversable wormhole. One could, in principle, pass through into the unknown. And then, inevitably, the next question arises. Where does it lead? Every telescope, probe, and listening post is brought to bear. Scanning the far side if possible, sending signals and waiting for echoes. Physicists and engineers devise plans to send small, expendable probes into the maw before risking anything larger or crude. The first probe launches, bearing an arsenal of scientific instruments and communication devices, fixed to send telemetry at all stages. Approaching the threshold, its cameras relay images of spatial distortion, a field of stars smeared and warped, light bending at impossible angles, color gradients stretching toward blackness. The probe transmits as it reaches the edge. To the world's amazement, the probe vanishes from regular space, only to reappear moments later with scrambled telemetry. Upon painstaking reconstruction of the data, the output confirms. It has emerged at an unknown location, distant from any star in humanity's catalogs, yet with a backlit glow similar to our own sun. The wormhole, it appears, connects to another region of space, perhaps within our galaxy, perhaps far beyond. Now, excitement mingles with awe and an undercurrent of fear. The possibility is obvious. Here is a route to a different part of the cosmos, far surpassing the arduous crawl of chemical rockets and interplanetary travel. If stable, this passage could make the stars accessible in ways previously confined to dreams. But there is a darker possibility. A wormhole needn't be a mere doorway. It can be a two-way street. What, if anything, lies on the other side? And more importantly, could something come through? For every scientist eager to explore, others caution vigilance. A stable, traversable wormhole could serve as a pathway for matter, energy, potentially even life. Agency after agency recommends a containment sphere, virtual or physical, a way to monitor and, if needed, seal whatever might threaten the Earth or the solar system at large. Suppose the anomaly proves benign. Detailed study of the wormhole yields revelations at every stage. First, physicists begin to map its gravitational influence, testing fundamental theories of relativity in regimes unreachable with any previous instrument. The bending of light around the wormhole's mouth allows for tests of Einstein's equations with unprecedented precision. Gravimeters and telescopic sensors catalog minute perturbations and, astonishingly, are able to trace not just the structure here, but the geometry on the far side. Spectroscopy of the other side environment, based on how the probe's signals altered upon transmission, reveals the local conditions, the temperature, the presence or absence of a nearby stellar atmosphere, the spectral lines distinctive of an alien sun. The next wave of exploration focuses on communication. Engineers transmit stronger signals through the wormhole, testing the response time, searching for interference or return transmissions. If the exit lies somewhere within our own galaxy, the data could provide hints about the galactic structure, the interstellar medium, perhaps even allow a crude mapping between wormhole location and known star systems. But the data remains ambiguous. The destination is uncertain, perhaps outside our galaxy, or within an uncharted region far from any previous probe's reach. The implications ignite a frenzy. Nations everywhere convene both in unity and in secrecy, negotiating protocols over possible encounters, debates raging between the open pursuit of scientific knowledge and the need for security. Small exploratory missions are planned, coordinated by international coalitions, with heavy precautions, both technological and biological. After all, Unknown regions may harbor dangers, high-energy radiation, microgravity environments, even potential pathogens or forms of life beyond our wildest imagining. Aboard the first human-crewed exploration vehicle are a team of astronauts, doctors, and scientists equipped to handle the unknown. The mission brief is simple: traverse the wormhole, report, and, if possible, return. Every nation watches anxiously as the vessel approaches, sending a final flurry of telemetry that shimmers and refracts as it crosses the threshold. What would explorers encounter upon emergence? Would it be a hostile cosmos, awash in dangerous radiation, black holes, or even some cosmic abyss? Or could it be a star system with planets, perhaps a world like our own, waiting on the far side? Each scenario brings the potential for new knowledge or new hazards. Critical questions abound. Is the passage one way, or will the explorers be able to return? Could the wormhole shift, strand travelers irretrievably? Is the structure naturally stable, or could it collapse with little warning? Precise calculations and continuous monitoring become an obsession, as scientists everywhere race to predict the wormhole's behavior. Suppose the crewed mission is successful. The wormhole stands open, and the explorers emerge in a region dotted with stars, perhaps within a distant globular cluster or orbiting an unfamiliar planet. By surveying from this new vantage point, the explorers could expand human knowledge of the universe exponentially, collecting data on distant astronomical phenomena, and perhaps even sending back material samples from realms previously unreachable. If so, humanity stands on the verge of a new era. The solar system's isolation shattered. Interstellar exploration, once thought impossible, shifts from fantasy to practical reality. New outposts could be established, robotic craft, and then perhaps colonists might follow. The question, what is out there, becomes almost limitless, horizons extending far beyond the familiar scope of our star. But such an opportunity also introduces chaos and challenge. How to monitor and defend a permanent gateway into the heart of our system? What if a hostile presence, technological or natural, exists at the far end? Even the gravitational effects of mass movement through the wormhole might destabilize planetary orbits or trigger unforeseen consequences. Each new possibility leads to further questions. Assuming the wormhole endures, research continues on every level. Teams of physicists observe, debate, and model the structure's internal geometry. The equations of general relativity are tested with unparalleled rigor. Quantum physicists study fluctuations and particle interactions within the throat, searching for the elusive signal of quantum gravity. Meanwhile, the public's imagination is captured. The wormhole becomes a symbol of hope, unity, anxiety, and wonder. Philosophers and theologians debate humanity's place in the cosmos as the gap between science fiction and reality narrows. Political leaders wrestle with the need for cooperation and the risks of conflict. New treaties are drafted, proposing shared stewardship or sometimes fierce claims over this cosmic passage. Suppose, one day, signals return from the other side, but not from our own explorers. Instead, the monitoring array detects a faint pulse, structured, repeating, undeniably artificial. Months of decoding reveal a rational order, mathematical patterns unambiguously crafted by intelligence. This, then, is the ultimate consequence: contact with another form of life, a moment as profound as humanity's first steps beyond Earth. The wormhole, it seems, links not just regions of space, but civilizations. Diplomacy must rapidly adapt as linguists and scientists work to understand and communicate. The risk is enormous, as is the opportunity. Yet even without such direct contact, the wormhole's mere existence forces the reevaluation of our understanding of the universe. Theories of cosmic evolution are updated, incorporating the possibility that such shortcuts might be widespread, perhaps even seeded by ancient intelligences, or occurring more often than we previously suspected. There would be ongoing danger as well. What if the wormhole's stability falters? A sudden collapse could have disastrous effects, releasing vast amounts of energy, distorting space in the vicinity, and potentially causing catastrophic consequences for any nearby planet or spacecraft. Contingency plans are developed, evacuation protocols, monitoring arrays, even the construction of massive structures to withstand gravitational shocks or contain unwanted matter. Even the mere existence of a new route through space brings legal and ethical quandaries. Who owns the wormhole? Who decides who may pass through? The solar system, once the exclusive home of humanity, now shares a doorway to infinity. Agriculture, technology, and biomedicine surge forward, fueled by discoveries made on new worlds, possible exchanges with distant civilizations, and a sense of collective purpose. The arts reflect a changed reality, with poets and painters struggling to capture the enormity of the event. New generations grow up never knowing the pre-wormhole world, their worldviews fixed on exploration, possibility, and sometimes the lurking dread of the unknown. Gradually, the extraordinary becomes commonplace. The wormhole, once an object of terror and awe, is mapped, monitored, and at last, integrated into the fabric of human experience. Regular traffic flows through. Research missions, cargo, perhaps tourists daring to cross the cosmic divide. Navigation charts now include the wormhole as a fixture, its risks and marvels understood if not fully mastered. There will always be outliers, those who fear the wormhole, who mistrust the unknown, who argue for its closure to preserve the sanctity and safety of the solar system. Arguments surface about contamination, both ways, about who has the right to profit, about the moral implications of discovery and conquest. Yet progress, once begun, is hard to stop. It is possible, even likely, that the discovery of a wormhole in the solar system would be the most transformative event in human history, changing not just technology, but every aspect of culture. Scientific textbooks are rewritten, history pivots on a new axis, and humanity, for the first time, truly steps into the wider universe. And so the formation of a wormhole within our solar system would be, in every sense, a new dawn. It would challenge and expand our understanding of physics, offer the possibility of exploration and encounter, test our unity, and ultimately redefine what it means to be human in a universe that is, suddenly, no longer so unfathomably vast. Yet, despite all preparation, humanity cannot know all the answers. The ultimate mystery of the wormhole, of where it leads, of what lies beyond, of whether we are alone or one among many, endures in the far reaches of the passage itself. With careful study, bold adventure, and a constant guard against hubris, perhaps we might find not just new worlds, but a deeper understanding of ourselves and the cosmos we inhabit. And thus, as the ages turn and the gateways of space open before us, the story of humanity stands forever changed, written not on the skin of the world, but now, at last, among the stars.